So, sulfides, am I right? How do we make them? Now, typically in organic one, you learn the reaction of H2SO4 addition to an alkene, and this will give you the SO4 addition to, or the SO3 addition to that alkene. Now, that is an option. You can further reduce down the SO3, SO4 groups down to the SH groups if that's your choice, but there's a more direct way if you want to make a sulfide. What we have to do is we have to break it into two steps. The first step is making our desired sulfide ion. So we can think about sulfide in two ways. The simplest is H2S, and this is going to give us an SH attachment, and we're going to see why in just a minute, why we're going to eliminate one of the hydrogens. The other is to start with a thiol, RSH, and attach this to it. Now, how do we attach it? Well, the first thing we have to do is add something like sodium metal. And yes, I know it isn't balanced, but we'll end up with NaHS plus hydrogen gas, or we'll end up with RS Na plus H2 gas. So in both these cases, we're abstracting one of the hydrogens off of sulfur using sodium as a reducing agent for the hydrogen, and we end up producing these organometallics. Now, we have to do this because what we really want to create, and what we do create here, is an S- and an Na+. And this S-, the sulfide ion here, is going to be our nucleophile. It's going to attack our organic species. So that's step one. We have to make our sulfide ion. The next step is to take an alkyl halide. Now, preferably we're going to hopefully react this for a substitution reaction. That said, particularly if this R group is very big, we may also favor elimination. So understand that there are going to be side products of alkenes formed. But ideally, we can work with an alkyl halide, ideally a good leaving group. I've got chlorine written up here. Honestly, iodine would be better. But if we react this with our sulfide ion, we will end up getting, our thiol ether. So if we want to create a thiol ether, we just have to react a thiol with an R group and use this nucleophilic substitution to eliminate an halogen on an alkyl halide to give us the thiol. Now, let's say we didn't have the starting thiol. How will we do it? Well, we just start with this, the H2S, react it with the sodium, and then use our sulfide ion, the HS- ion, to attack and give us our thiol. But this is how we would create thiols. Now, let's say you want to do something different. Let's say you actually want to create like an SO group, SO2 or SO3 group. Stick around the next video. We'll talk about how to take your resulting thiol and convert it to like a sulfonyl or sulfoxide complex.